Hey there, everybody. We're going to talk about one of the units that is a lot of people's most favoritist thing in 7th, 8th grade math in pre-algebra. It's when you start getting to graph on something called the coordinate plane, but for some reason, I think because you get to see it and move things around and visualize it, it just makes it a little bit easier, okay? So we're going to talk about the coordinate plane. Now the first thing is if you don't remember it very well, I've got things already started here where I've labeled this as the x-axis, okay, and the vertical axis is the y-axis, okay. And so if you want to label a point, like I've got this coordinate s right here, you always want to go and list your x and then your y. A lot of people mix those up, but you put the x number first, comma, the y number. So when you're moving to the right, okay, your x's in this quadrant are positive. These are positive x's, and over here, these are negative x's. And the same thing, this makes sense on the vertical, because if you go up, you're going positive, and if you go down, you're going negative. So this is kind of how you work it. So right is positive and up is positive, left is negative and down is negative. And this, by the way, is called the origin. I think a lot of you know that, but just in case. Okay, so in other words, to get to this s, you just want to count from here. I need to go over 1, 2, 3, 4. Go over 4. So I put that number first because that's on the x-axis. Notice I kept it positive 4 because I'm going this way. And then the y, I just went up 2. Now if I went up 2, now I'm going positive 2, okay? So that's how you label a point. And in fact, some people, some teachers, want you to often start off the year memorizing the quadrants and what's positive and what's negative. So in this quadrant, everything's positive because you're going right and up. In this quadrant, you're going left and then up. So the x's will be negative and the y's will be positive. What about here? Here I'm going left, so that's negative. Then I'm going down, so that's negative. And then in this quadrant, I go to the right, which means it's a positive x, but then I go down, which means it's a negative y. So that's how your points will look with positives and negatives, depending on what quadrant you're in. Now, a quadrant is just the word used to describe which region of the graph that you're in, and they do have specific names. This one is quadrant 1, and I'm going to use Roman numerals here. This is quadrant 2, this is quadrant 3, and this is quadrant 4, okay? Now, quadrants 1, 2, 3, and 4, notice it went around counterclockwise. The way that I used to ask students to remember it at your age was, this is called the coordinate plane, right? Coordinate plane. And this coordinate starts with a C. And if you draw the letter C, how do you draw a C? Well, usually you start here and you go around to draw a C, right? So C for coordinate plane, and notice where you start the C is where you start quadrant 1, and then 2, 3, 4. So that's just a little memory trick to help you out, okay? And what we're going to talk about today is just points and moving around and things that you can do to a point to get to other places on your coordinate plane, okay? So the fancy word for this is transformations. Now, transformations includes the following: reflections, translations, dilations, and rotations. A lot of ations, huh? Haha. Okay. So all of these are things that you will be doing. Now, some of them you'll do this year, some of them you'll do next year, some of them you actually won't do till you're like a junior in high school. But I wanted to let you know all 4 of these really are part of what is encompassed with the transformation. And we're going to do a few of them today. A reflection, I love the reflection one. Okay, a reflection, you know, if you think about it, what's a reflection in the mirror? Well, It's an image that's just reflected or looking back on you. And what'll happen a lot of times is you may be asked to reflect across a specific place. So what we're going to work on first is a reflection across the x-axis, okay? What this means is if the x-axis is your mirror, okay? If the x-axis is your mirror, it's almost like what's the image of S inside of the mirror? So beyond this, where would that S end up? Now, I like to think of it not just as a mirror, but you may remember as a kid you would sometimes take a piece of paper and you would blot down a big piece of paint on one side of your paper. Then you would fold the piece of paper, and what would happen? Well, when you fold it, your big blob of paint would end up on another part of your picture, right? So I always like to imagine, okay, well, what if I fold my paper on this x-axis? Where would that big blob of paint end up? Well, it would be right here, right? I'm folding here, so this piece would touch up with this piece whenever I fold my piece of paper down. And so that is a reflection across the x-axis. Now, typically, whenever you reflect a point, the original point is called the pre-image. So wherever the original point was is the pre-image, and this new point down here is sometimes just called the image or the new image, and it gets a different label. You don't want to call it S because that is S, but it's like S, it's just been moved, and so a lot of times people just rewrite the S, but then they put a little, it almost looks like an apostrophe right there. That apostrophe in math is not called an apostrophe, it is called a prime. So it would be read S prime, but yes, it does look like an apostrophe, okay? So the S prime is just the new image of S and where it is moved. So why don't you try this one? Hit pause. We're going to reflect it now across the y-axis. Hit pause. Try to see if you can think of where it would go and label it with its new label, and then hit play again and see if you got it right. Okay, so right here is where we're folding our piece of paper or our mirror image. S is over here, and it's going to end up somewhere over here. Now, to make sure it goes in the exact spot, because this is my big blob of paint, it is 1, 2, 3, 4 away right here, so it needs to be 1, 2, 3, 4 away right here, and I would label it with an S prime, okay? Now, sometimes you may be asked to actually write the name of the point, so hopefully you drew that right. But if you write the name of the point, just count. You know, I'm going 1, 2, 3, 4 in this direction, so it's a -4. And then I went up 2, so it's a +2 because I'm in quadrant 3. X is negative, Y is positive, okay? So anyway, so that's kind of how that works. Just pay attention to how far away. We did that here. It was just kind of in our heads. This is 2 away. That's 2 away. This is 1, 2, 3, 4 away. This is 1, 2, 3, 4 away. So it's just a counting game. All right, cool. So I like reflections. Those are pretty easy. All right, translations. Most people actually think translations are the easiest. Translation is any time you are shifting the point left or right, or both. It could be a combination of both. So shifting left or right, or both. So a translation, since it's just a shift, let's try to make up a couple of examples. So on this one, let's shift left 3 spaces. And you know what? It would probably say units. Let me delete this. It would say, why isn't it deleting? Okay, it didn't want to delete, but there we go. Okay, so 3 units. All right, so if we want to shift it 3 units, it is just that easy, everybody. You put your finger on S and you go 1, 2, 3 units to the left. So the hardest thing here is you better know your left versus right, okay? But other than that, that's it. And then you write the new point. Well, it's an S with the prime, right, because it's the new S, and I'm going to go, that point is over 1 on the x-axis, and then up 2 on the y-axis. So that's pretty much it. So let's try to do one over here. Let's shift 2 units down. Let's do a multiple one. And 5 units left. Okay, if you want to try it on your own, hit pause and try it and come back. But I'm going to go ahead and start. 2 units down, 1, 2, and then 5 units left. 1, 2, 3, 4, 5. So it ends up here, so you have to do both at the same time. This is my new S, and I am, where am I? I'm over 1 on the x-axis, so that would be a -1 because it's to the left of the origin. And then how much have I gone up or down on the y? 0, a big fat 0. So that would be the point -1, 0. Okay, and we are not doing dilations or rotations today, but you may see them. I do want you to jump down here real quick and write those 2 words down. And we're just going to kind of write what they are, rotations. Okay, a dilation, guys, is if you've ever been to the eye doctor and they've dilated your pupils, it's making your pupils bigger, okay? So that's what a dilation does. A dilation is it changes the size of your shape. And we haven't done a shape yet, but you probably already saw it. I'm not ruining any surprise here. We're about to do a triangle. So a dilation would change the size of the triangle. A rotation is when you turn, rotate, spin the object around a certain point. So I don't know. These are tricky. I'm not sure how much you'll do this year or how much you'll wait on until high school, but it won't be enough for us to actually do it in this video. I really think this will be later, okay? All right, so moving more than just a single coordinate. So let's pretend that you know this point, and I'm going to go ahead and label these. Pretend that I had labeled them on your sheet. Let's call this T, this R, and this S, and let's pretend that this said, maybe it's going to say, what's it going to say? Let's do a reflection. Maybe it's going to say reflect triangle RST across the y-axis. Okay? So what you're going to have to do is be careful and go, okay, what? So you're just going to want to do this one point at a time. The first thing I'm going to do is just kind of put a line or something across my y so I can see what I'm actually trying to reflect across. And just look one at a time, okay? Look at R. R is 1 away right here, so when I fold my piece of paper, that big dot is going to now be there. And I'm going to go ahead and label it with an R prime right off the bat, okay? Now, if you don't like having clutter with all these lines, then don't do them. You can erase those if you want, because some of y'all probably do see these pretty well where you don't need to know. Yeah, you don't need that maybe. Okay, let's do S. Okay, S is, we'll do that in blue, S is 1, 2, 3, 4 away, so I need to go 1, 2, 3, 4 away across the y-axis, and I'm going to label that with my new S. And then my T is right here, and it's 1 away on the left, so now I need to go 1 away on the right. It'll flip to this side, and it'll be my T prime. Now, once you've drawn the 3 new vertices, so I'm just going to say reflect each point, or let's call them the vertex. Reflect each vertex first, then play connect the dots. This is going to help you make a really nice straight triangle at the very end, okay? Because we know it's going to be a triangle, so then we just connect all of these guys together. Oh my gosh, I drew to the wrong one, see? That's why you label these. Okay, that doesn't go there. They go to the T with the prime on it, duh. Okay, So R prime, S prime, and T prime are the three that you need to connect now. And it looks something like that, right? So not bad. So it's this whole triangle's been flipped across the y-axis, and it'll look like that. So just go slow, do one at a time, and I think for a lot of you this will be your most, like I said, most favoritist thing. I know that my grammar is terrible, but that's why I'm a math teacher. All right, have fun trying your homework, and I think you actually will have fun with this one, and we will see you later in tutorials or next week in video.